Hi everyone. Today we're learning about atomic models. So we're going to look at some atoms. Not real ones, of course. Real atoms are about 1 to 2 angstroms wide, and that is equal to 10 to the negative 10 meters. So you can't see them. And even if you could see that size, they're mostly empty space anyway, except for the nucleus, and that is about 10 to the negative 14 meters. Also, two of the models I'm going to show you are just wrong, so even if they were big enough, you wouldn't be seeing them in real life. And that is why I decided to make animated models. So let's get started. The first model I'm going to show you is called the plum pudding model, which was discovered by J.J. Thomson after his cathode ray experiment. He directed cathode rays at atoms and found that small negative charges were deflecting them. These small negative charges are now known as electrons. And Thomson believed that electrons were embedded in a large positive charge because everyone knew that atoms were neutral before this experiment. Or at least that was the scientific consensus. I wouldn't be surprised if back then they also had science deniers. So, according to this model, atoms have a positively charged shell and free floating electrons, which I guess is supposed to resemble a plum pudding. Next, we have the Rutherford model, discovered by, you guessed it, Rutherford. He conducted a gold foil experiment, which consisted of aiming alpha particles at a piece of gold foil. He noticed that most of the particles just passed straight through the foil, as if there was nothing there at all, and only a small percentage were deflected at large angles, with about 1 in 8,000 being deflected straight back at him. These alpha particles must have been deflected by what Rutherford called the nucleus, which must be small and dense and in the center of the atom. And everything else must be empty space if the alpha particles were able to pass straight through it. Electrons, he believed, would orbit the nucleus, sort of like planets around the sun. Bohr later improved this model by incorporating some early quantum theory. This leads us to the quantum model, which is also known as the electron cloud model. An electron cloud is basically just a probability model of where an electron is likely to be. If the cloud has a high density, that means the electron is more likely to be there. These clouds form the s, p, d, and f orbitals. Sometimes, if an electron gains enough energy, it can transfer to a higher energy level, as we can see in our animation. You might be wondering why you should care what atoms look like, because you can't even see them in the first place. But it still matters, and that's because it's literally matter. So of course it should matter. The quantum model of the atom explains how instantaneous dipoles can form, because if the electrons have enough energy, they can all move to one side of the atom, and that side will get a partial negative charge while the other gets a partial positive. So there's a dipole induced in the atom. If this happens to enough atoms in the medium, then there will be London dispersion forces that attract all the atoms. This model also explains covalent bonding because one orbital can easily accommodate electrons from another atom, and double and triple bonding is very easy in this model. And we see double and triple bonds in things like oxygen and organic molecules. So, and I assume you're not cyborgs, you all breathe air and eat food, and that is possible because of the quantum model of the atom. Thank you for listening. Sources will be linked in the description.